The story of Ethernet is best told in personal stories shared by its very own creators, providers, and users. The Voices of Ethernet archive is dedicated to preserving Ethernet's oral history, recording pivotal events that may have been forgotten or remain unknown, through a collection of spoken records with the individuals engaged in the technology's global emergence as the foundation of Internet.
So today for Voices of Ethernet, we're talking to Tony Jeffree. Tony, thanks for joining us. Could you please introduce yourself?
Thanks, Peter. I've been involved in IT since 1975 and in Ethernet since 1984. My first career was as a software engineer. I was initially working on the development of process control systems using PDP-8s and punch paper tape and exciting stuff like that. Later moved into fairly rudimentary bits of data communications, and then later still into Ethernet, and then took a detour into consultancy around about the early 80s, and stuck with that for pretty much the rest of my career, going freelance in 1996, and up until 2016, I was working for myself, and I have to say I was probably the worst boss I ever worked for.
There are a whole lot of conversations about the joys of working for yourself.
Indeed, indeed. It's an interesting trip, but mostly I enjoyed it. It was good.
So tell us a little bit about like how and when and why did you get involved in the Ethernet/standards world?
Well, I first came across Ethernet actually before 1984. Right? I was working for a little software house, and we were messing around with various bits of terminal emulation using the emerging microcomputers that were appearing at the time, Commodore PETs and IBM PC.
You wrote Telnet.
Yeah, and we briefly looked at the Xerox standards as they were at that time for Ethernet, and thought, 10 megabits per second? You're joking.
No one will ever need it this fast.
Who would ever need it this fast? Absolutely. And so we passed over that, and quite soon after, I got recruited by IEEE Data Networks, who at the time were one of the emerging companies in the Ethernet yellow cable network business, and they were building transceivers and selling them in large quantities to guys your side of the pond. And it was a company that was very much standards based, and continued to be so while I was with them. And they sent people to 802.3 to see what was going on, and also to help develop the standards, as you do. And one of these guys noticed that 802.1 was in existence and was looking at network management standards. And I'd been recruited to the IEEE Data Networks to work on their Ethernet controller for the IBM PC. So they stuck me on a plane in November '84 and sent me off to my first 802 meeting. Little knowing that this was not going to be my last by a long stretch. And I got stuck into 802.1 network management and stayed involved in that for several years, up until '93, when I took a short vacation from standards activities, and came back to it in '95 when 3Com were looking for somebody to help in .1 to write the standard that became 802.1p.
Most people today, when they think about 802 standards, don't think about network management. So going back in time, right, what was the drive to go to do this?
I guess the drive from BICC's point of view was differentiation, as is often the case with products. You need to be able to not only make sure the thing works, but also show, hey, we've got more bells and whistles than you've got. But in those days, I mean, looking back on it, it's hard to see what real value add was going to be offered by network management on a PC card and an IBM PC in a rudimentary 10 megabit per second network. When we look at the networks of today, the idea of building anything significant without network management is kind of a joke. I mean, even I've been amusing myself with implementing Ethernet and Wi-Fi in our pub, but these days, even a village pub needs data communications, and it needed a decent Ethernet system. So I've ended up implementing something that has got a network management node on it. I mean, it's got three Wi-Fi access points and a network management node. I mean, how cool is that?
So when you go back to when you showed up, I assume at that stage the culture war between .3, .4, and .5 was still alive and well.
Oh, very much so. And it continued to be very much alive and well until well after I returned from my break in 93 and came back in 95 to work on .1p. I mean, at that point, we still had the wars going on between .5 and .1 with regard to map bridging, and we'd basically reached the point where we had a bridging standard in .1, and the .5 guys still wanted their source routing bridge to be standardized. And the agreement we had with them was, well, you go away and tell us how you're going to integrate source routing into the .1 bridge, the .1 transparent bridge. And so the so-called SRTB, source routing transparent bridge, came into temporary existence, at least in name, if not in substance. And there was an entertaining series of meetings at which, to
when you say entertaining, this is for a particular class of entertaining.
It is, yes, under some meaning of entertaining, where to use Mick Siemens' words, we would have a talk with them about what they were doing, and then they would say, well, we've got these problems, and so we would come up with an idea that they might consider between then and the subsequent meeting. And to quote Mick Siemens, these suggestions were all plausible, enticing, and non-trivial.
Why don't you chase this shiny object for a while?
Yes, indeed. Chase this shiny object for a while, and then come back in 2 months' time, and we'll have another discussion with you, and we'll tell you why it doesn't work.
So I realize we did skip over a little. So most people know about .3, and so how would you describe the split in responsibility between .3 and .1? Like what did .1 do that was key? Well,
two kinds of things that .1 did. The first was almost incidentally providing a means whereby full duplex Ethernet could be extended almost indefinitely in size by sticking it together with bridges, and at the same time using filtering in the bridges to reduce the amount of traffic that each node doesn't need to see, if you follow me. So that was one.
So that's an interesting one. We should dig into that just a little bit, because there's a difference between layer 2 and layer 3, and most people don't realize it.
Yes, most people don't realize it. Most people talk about layer 2 as being, a layer in which no filtering and no routing happens. Yes. We successfully maintained the fiction for many years that the 802.1 MAC bridge is not a router. It's a filtering device. It filters frames. It doesn't route them. This is, of course, complete baloney. It's a layer 2 router. Get over it, guys. And at the end of the day, that's the reality. It routes frames. It's not a router in the sense of being an IP router, but it is a router nonetheless.
The way I always heard about it was that layer 3 sends it to where you send the packets to where you think they should go.
Yeah.
And layer 2, you send them to where you're pretty sure they shouldn't. So you don't send them to where you're pretty sure they shouldn't go.
That's certainly the simplistic view of it. The rather more complex view starts to appear when you look at the added complexity that 802.1 added to bridges later on. Things like stuff that allows you basically to nail down a circuit in a LAN and it makes it look very much like a connection-oriented device. But anyhow, I mean that's kind of, yeah. I mean the simple answer is, as you say, .1 bridges filter frames from the places that they're not needed, whereas an IP router sends them to where they are needed. It comes to the same thing. It's just a different mechanism.
So you alluded earlier to .1 people who started doing priorities, and I think that probably natively hooks into things like VLANs. So do you want to take us a bit through that journey?
It does indeed. And when a few minutes ago I was talking about two things that the .1 did for the synergy of the Ethernet and .1, this starts into the other half of it, which is adding value to the Ethernet frame, essentially. .1p added capability in bridges to prioritize frames, and so you could label a frame as it enters a bridge and say this is priority X, and then on the outbound ports decide whether you're going to transmit or not, depending on whether there were higher priority frames waiting to be transmitted, and if there were, then the priority X frame would wait until a slot was available.
Yeah, on the priority question, right, Magic. So why did you end up with 8 priorities? Because I mean, long term down the line, that became an issue. My guess is it's another case of who would need more than this.
Kind of, yes, yeah. That's. I mean, if you looked at the other technologies in 802 at the time, 8 was the biggest number that we had to deal with. Token Ring had 8. Token Bus, I forget actually. Did it have 8? It certainly had more than one. I can't remember, but 8 seemed to be the magic number. And the VLAN activity, which followed very closely behind .1p, added the ability to put those priorities actually into the Ethernet frame. .1p on its own would only allow the ports to behave as if they had priorities. .1q added the ability to signal in the frame what the frame priority was and carry that end to end.
I can imagine that the starting conversation for this VLAN thing must have been exciting, with people having to adopt fundamentally new positions the way they saw the world.
Very much so. And actually, to begin with, there was a lot of resistance amongst the sort of 802.1 old school of guys who didn't see the need for this stuff. What do we need VLANs for? It was rapidly apparent that there was a lot of industry pressure behind this, and companies that had implemented VLAN schemes on one or more different bases. So we did the usual thing of raising a PAR and starting a project.
Of raising a what?
A PAR, project authorization request. It's a scoping document for a project, and the end result of a project in IEEE standards world is a standard. It's a standards document, and the PAR dies at the point where the standard gets published. So the old school elements in .1 wanted to make sure that the purity of the bridging standard was maintained.
At this stage, I'm going to point out the interesting thing of neither of us are particularly young, and we're describing the old school as the people who were there before us.
Well, I was one of them. I mean, the old school, as in the the .1 people that were there already, as opposed to the newcomers that were coming in and saying we want VLANs. So anyhow, we felt that the whole sort of VLAN project was sufficiently risky that it was worth keeping it as a separate standard from 802.1d, which was the bridging standard, at least in the initial stages. And it stayed that way, and for quite a few years, and was eventually reunified back into .1d. Well, and actually it was the other way around. .1d was reunified into .1q, into the VLAN standard.
Before we dive too far away from this, can you give me a few words on how Spanning Tree became Spanning Tree?
How Spanning Tree became Spanning Tree? Well, the original Spanning Tree was invented by Radio Perlman. It was a result of a paper that she wrote when she was working at Digital. And the idea basically is that if you construct a mesh topology in Ethernet, you've got all kinds of problems, because frames circulate endlessly, and therefore you have to find some way of reducing that mesh topology to a tree structure. And hence Spanning Tree, you wanted it to be tree structured, and you want it to span the entire network, so all nodes are included.
Yep. And
there's an arc between any one node and its immediate neighbor that allows you to reach all parts of the network. The problem with Spanning Tree in its original form was that it wasn't very quick, and worst case, in a maximally sized network, 30 seconds to reconfigure if you broke a link. I mean, this is madness, guys. People could die in that intervening 30 seconds, and you would have no way of dealing with it. And we needed to fix that one way or another. And Mick Seaman had a really quite major brainwave when he realized that if you have a tree structure and you snip off a branch of that tree, you can reconnect it to the end of any other branch, and the tree is still a spanning tree.
Okay, I got that. You basically you
chop off a limb. Tree. You can move a chunk of a tree to any other end node on any other branch of the tree, and attach it there, and connectivity is restored, and it's still a spanning tree.
I don't think I understood that. I'm sure I looked at it, but I never actually thought about it that way. So somewhere in there, you did the transition from editing as sort of being a major contributor to actually running the group. I'm just sort of wondering, like, how and why. Like, why did you take on that task?
Because I was asked to, I think, is the short answer to that. Bill Ladinsky, who was the first chair of .1, basically dropped out of 802 activities in 2000, and that was partly because at the time there was a sort of sunset clause on repeated re-election of chairman, that you couldn't be re-elected more than X number of times before you had to pass the baton on to somebody else, and so he used this to basically terminate his activity in 802. He decided to give up at that point, and I was asked to take over, and also given an offering of funding to do it. So why not? It's a very different role, obviously. Attempting to run the group as well as editing standards is kind of, it makes your life pretty hectic at times.
You need to be very clear which hat you're wearing. Is it individual contributor, editor, or chair? Because they're very different behaviors.
Yes, yes, indeed. And I mean, I shall leave it to others to pass judgment on how well I managed that multiple hat wearing. But I stayed in that role for 14 years, from 2000 to 2014.
Well, you can't have done that badly.
Well, either that or everybody else was saying, well, we don't want to go there.
So, sort of along that, you did a sideline into the Registration Authority Committee, or the RAC, and probably most people out there have no idea what that actually is.
Okay, well, the RAC, the Registration Authority Committee, is the policy making body that sits behind the IEEE Registration Authority. Surprise, surprise. The Registration Authority is an assigned numbers registry organization. It keeps registries of assigned numbers. If you want one of those families of assigned numbers, you go to them.
And an assigned number is,
for example, a block of Ethernet addresses, and that's the most commonly known registry that the IEEE maintains. But there are a bunch of ones that go alongside it, which are rather lesser known, but nonetheless valuable to those that care about them.
Tune in to hear other voices of Ethernet as we continue to document the evolution of Ethernet since 1973 and explore where the technology's story might go next. Thanks for joining.